This is Bob Capetta from the University of Illinois at Chicago, and this lesson is on implicit derivatives. We'll start with our basics. The derivative with respect to x of x is 1. We know the derivative of x is 1, but we need to know what variable we're interested in. The derivative with respect to x of x, the x's match, and the answer is just 1. But if I take the derivative with respect to x of y, that is dy dx. That'll be important for us to know. And in later lessons, we'll take a look at t as an independent variable. So if I have the derivative with respect to t of x, that would be dx dt. And the derivative with respect to t of y would be dy dt. So you just can't say the derivative of, you've got to say the derivative with respect to which variable, which is why I prefer the dy dx notation to y prime, where it's not clear what the independent variable is. So let's recall the chain rule for powers. The derivative of something to the n is n times something to the n minus 1 times the derivative with respect to x of that something. So we want to make sure that we are matching our independent variables here. So the derivative of something to the third power would be 3 times the something squared times the derivative of the something. Of course, the derivative with respect to x is our issue in both cases. So if I've got the derivative with respect to x of y cubed, that would be 3 times y squared times the derivative with respect to x of y. But the derivative with respect to x of y is dy dx. So that result becomes 3y squared dy dx. So whenever these variables don't match, the derivative with respect to x here and a function of y here, you're going to hook on something like a dy dx. That'll be important for us to keep in mind. Also recall the product rule. The derivative with respect to x of u times v is u prime v plus uv prime. But again, u prime and v prime aren't clear. U prime really means the derivative with respect to x of u. V prime really means the derivative with respect to x of v, since we're starting with the derivative with respect to x on the outside. So rethinking this, the derivative with respect to x of u times v is the derivative of the first piece. That's the derivative with respect to x of u times v, plus the first piece, u times the derivative of the second piece, the derivative with respect to x of v. So if I want to take the derivative with respect to x of 3x squared y to the fifth, I have to define u and define v. Remembering, of course, that the derivative with respect to x of uv is u prime v plus uv prime. I'm going to let u equal 3x squared and v equals y to the fifth. Now u prime will be the derivative with respect to x of this. The derivative with respect to x of 3x squared is just 6x. But v prime is the derivative with respect to x of y to the fifth. That's going to require a little bit more work. So again, this piece is just 6x. This piece, the derivative of something to the fifth power, 5 times the something to the fourth, 5y to the fourth, times the derivative with respect to x of the something times dy dx. Again, thinking of the something here, 5 times y to the fourth times the derivative with respect to x of y. And the derivative with respect to x of y is dy dx. U prime, since the variables match, the derivative with respect to x of 3x squared is just 6x, no issue there. Now to take the derivative with respect to x of 3x squared y to the fifth, it'll be u prime v, 6x times y to the fifth plus uv prime plus 3x squared times 5y to the fourth dy dx. So there's our information, there is our product rule. And there you go, u prime v, 6x times y to the fifth, plus u, 3x squared, times 5y to the fourth dy dx. Cleaning that up a little bit, 3x squared times 5y to the fourth would be 15x squared y to the fourth dy dx. So our final answer for the derivative with respect to x of 3x squared y to the fifth is 6x y to the fifth plus 15x squared y to the fourth dy dx. Now we're given an equation. We're given x squared plus y squared plus 4x minus 6y equals 10. And our goal is to find dy dx. To do this, we'll take the derivative with respect to x of both sides. And we know the derivative of the sum is the sum of the derivatives. So the left side will be the derivative with respect to x of x squared plus the derivative with respect to x of y squared plus the derivative with respect to x of 4x minus the derivative with respect to x of 6y. Derivative with respect to x of x squared is 2x, we know that. The derivative with respect to x of 4x is 4, we know that. The derivative with respect to x of 10 is 0, we know that. This is going to require a little bit of work, and this is going to require a little bit of work. But the first thing I did is I just pulled the 4 out. So this is 4 times the derivative with respect to x of x minus 6 times the derivative with respect to x of y. The derivative with respect to x of x squared is 2x. Now, the derivative with respect to x of y squared, something squared. 2 times y to the first times the derivative with respect to x of the something of the y. The derivative with respect to x of y is just dy dx. The derivative with respect to x of x is just 1, hence 4 times 1. The derivative with respect to x of y is dy dx. And the derivative with respect to x of 10 is just 0. Now my goal is to solve for dy dx. So I'm going to want to have all the dy dx on one side, on the left side. Anything that doesn't have a dy dx is going to have to be moved to the right side. So I will have to subtract 2x and subtract 4 from both sides to isolate the dy dx on the left side. So subtracting 2x from both sides, looks like I've made an error here, I will fix. And it's fixed. So from the previous page we have 2x plus 2y dy dx plus 4 minus 6 dy dx equals 0. We want to have the dy dx's on the left side, everything else on the other. I will need to subtract 2x and 4 from both sides. So subtract 2x from the left, subtract 4 from the left, subtract 2x from the right, subtract 4 from the right. So the 2x's are gone, the 4's are gone. We'll have 2y dy dx minus 6 dy dx equals 0 minus 2x minus 4, or negative 2x minus 4. Factoring out the dy dx from the left side, then I get dy dx times 2y minus 6 equals negative 2x minus 4. Divide both sides by the 2y minus 6, and we have dy dx is negative 2x minus 4 over 2y minus 6. And this can be reduced. I'll factor a 2 out of the numerator, factor a 2 out of the denominator. So in the numerator I have 2 times negative x minus 2, in the denominator 2 times y minus 3. Those two divide out, and we get dy dx is negative x minus 2 over y minus 3. Our next example is the following. 3x squared plus 4x cubed y squared minus 7y equals 5x plus 2y cubed, and again we want to find dy dx. We'll take the derivative with respect to x of both sides. The derivative of the sum is the sum of the derivatives, so derivative of the first piece plus the derivative of the second piece minus the derivative of the third piece equals the derivative of the first piece plus the derivative of the second piece. The derivative with respect to x of 3x squared is just 6x. This one will work on. The derivative with respect to x of 5x is 5, and this one has a y. So we need to do a little bit of work with these pieces that have y's in them. The ones that are just functions of x, we just take the regular derivatives. What I want to do next is I want to do the derivative of this 4x cubed y squared piece, which will require the product rule. So u will be 4x cubed, v will be y squared. U prime, the derivative with respect to x of 4x cubed, that will just be 12x squared because the variables match. That's not going to be a problem. The derivative with respect to x of y squared of something squared, 2 times the something, 2 times y, times the derivative with respect to x of the something times dy dx. So u prime again, 12x squared, v prime will be 2y d dx of y dy dx. So to do this derivative with respect to x of 4x cubed y squared, I need u prime v, 12x squared y squared plus uv prime plus 4x cubed times 2y dy dx. So again, our uv, u prime, v prime, there's our product rule, u prime v plus uv prime. U prime v, 12x squared times y squared plus u, 4x cubed v prime, 2y dy dx. And of course, 4x cubed times 2y would be 8x cubed y dy dx. So that is just for this piece here, the derivative with respect to x of 4x cubed y cubed, we will substitute 12x squared y squared plus 8x cubed y dy dx. Here is that piece being substituted. Now, we still have to go ahead and do this piece and this piece. And the first thing I'm going to do is I'm going to pull the constants out, pull the 7 out in front, pull the 2 out in front. The derivative with respect to x of y is just dy dx. The derivative with respect to x of y cubed would be 3y squared times the derivative with respect to x of y, 3y squared dy dx. So our next move is to isolate the dy dx's, get all the dy dx's on one side, get everything else on the other side. So let's see if we can do that. I'm going to need to subtract 6x, 12x squared y squared from both sides so that I get everything away from the dy dx's. Subtract 6x, subtract 12x squared y squared, subtract 6x, subtract 12x squared y squared. Now all that's left on the left side is 8x cubed y dy dx minus 7 dy dx. All that's left on the right side, 5 minus 6x minus 12x squared y squared plus 6y squared dy dx. I do not have all the dy dx's on the left, so I'll subtract 6y squared dy dx from both sides to get that to happen. So subtracting 6y squared dy dx from the right side, subtract 6y squared dy dx from the left side. Now I've isolated all the dy dx's on the left. We'll have 8x cubed y dy dx minus 7 dy dx minus 6y squared dy dx will equal 5 minus 6x minus 12x squared y squared. Next up is to factor the dy dx on the left side. So removing that, we'll have dy dx times 8x cubed y minus 7 minus 6y squared equals 5 minus 6x minus 12x squared y squared. Then I will divide both sides by what's multiplying dy dx, and that is 8x cubed y minus 7 minus 6y squared. And that is dy dx based on our original function. And that will conclude this lesson.